Hello everyone, the teen engineer here, and today we have another physics problem. So this problem involves dynamics, and I think that should be pretty much it. Just dynamics, I think. So yeah, let's read it. Two small balls A and B are attached by massless ropes to a center post as shown. Each ball is traveling at a constant speed in a horizontal circle around the post. Rope 1, joining A to the center post, makes an angle of 30 degrees with the vertical, and rope 2 makes an angle of 36.9 degrees with the vertical. Rope 1 is 1.5 meters long and has a tension 3.58 newtons. Rope 2 has a tension 0.75 newtons. At this instant, balls A and B have a velocity pointing into the sheet. All following questions apply to the instant shown. Your answers to D, E must either include a stated direction or to be expressed in terms of unit vector notation. All right, so let's draw a free body diagram for both balls at the instant shown and provide your coordinate system. All right, so I'm just going to move this over here. So this is for A. So let's draw for A first. I'm just going to make that smaller. So free body diagram, I'm going to make that y-axis, the x-axis as well. Now, let's define the direction of acceleration, and I'm going to make it, well, we can see that in this instant it has to be pointing towards the radius all the time. So at that instant it's this side. So x, let's make x at the same direction to simplify our lives. And the first thing I can see here always is usually the gravitational force. So I'm going to say weight of A. We also have the tension of rope 1. So I'm going to make that here and that here, just like that. So we're going to name that tension 1. Weight 1, okay. And then let's just write what this angle is. It is 30 degrees. It's an alternate angle with this one, so if you were to draw it here, that's 30. These are the same. Then we have the tension 2 pulling it down at an angle of 36.9 degrees with the y-axis. So something like this. Tension 2. Here, and let's write the angle 36.9 degrees. Now I'm also going to separate the tension 1 and tension 2 into the x and y forces, just to simplify our lives. So tension 1, this force over here is going to be, this would be tension 1 sine of 30. This is this force over here, and then over here we would have tension 1, and that will be a cosine of 30. So yeah, and now do the same for tension 2. And this one is tension 2 sine 36.9, and then one down. Oops, let's make that nicer, just like that. That'll be tension 2 cos of 36.9. All right, so that's done for A. Now let's do it for B as well. So B, let's make it again. Right, now the acceleration is, let me just remake that. Now the acceleration is in that, pointing in that direction. Let's make that x. and y. You should always make the coordinates system the same direction as the acceleration, just to simplify your life. So the b, well, there's the weight. So the weight of b. There is the tension too. So over here we have T2, and that's an alternate angle with this one. So this will be the same angle. That's 36.9. 36.9 over here. And then that is it for B. But I'm going to separate T2 into X and Y. So like that. That's T2. And that will be sine of 36.9. And then here it will be T2 cos 36.9. Okay, so that is it. So part A is finished. Let me just remove it. Find coordinate system, that's fine. Next, find the mass of ball A. We want to find the mass of ball A. Okay, so let's write our equations over here. I'm just gonna move out. Want to find the mass of ball A, so I'm just gonna separate it. These are free body diagrams. So let's write the forces for A. We have sum of forces in, let's do X first. So sum of forces in X is equal to T1 sine of 30 minus T2 sine of 36.9. T2 sine of 30. T2 sine 36.9. And that is it. So that equals to, since there's acceleration, this would equal mass times acceleration. So mass of A times acceleration. All right. Now we have for the y as well. Let's do that. So sum of forces in y is equal to, now we have T1 cos of 30 minus T2 cos of 36.9 minus the weight of the ball. And that is 0 because in a y it's not, there's no acceleration in y, it's only in x. So that's done for A. Now let's do that same thing for B. So sum of forces in X is equal to, we only have one force in X, and that's T2 sine of 36.9. And that's also equal to, since there's acceleration in X, that's also equal to the mass times acceleration. And in Y, that's equal, with the sum of forces in Y is, well, we have T2 cos of 36.9 minus the weight of the ball, and that's equal to 0 since there is no acceleration in y. So let's have a look. So we have to find the mass of ball A. So we have the mass of ball A here in this equation. We also have it here because the weight technically includes the mass. We also have the tension. So rope 2 has tension 0.75. I'm going to write these. So rope 1 has tension T1 is equal to 3.58 and T2 is 0.75. All right, so now that we have these, we can have a look. So we have T1, we have T2, but we don't have the acceleration or the mass. So this, we can't do anything with alone with the first equation. Second equation, we have T1, we have T2, and we can find the weight, which means we can find the mass. So let's do that. Oops. So this one, let's replace. So T1 was 3.58. Yeah, 3.58. So 3.58 cosine of 30 minus, and that the other one was 0.75 cosine at 36.9 minus weight of A is equal to 0. So let's just do that. So 3.8 cosine of 30 minus 0.75 cosine of 36.9. So that is 2.69. 2.69 minus weight of A is equal to 0. Let's bring weight of A to the other side. So 2.69 is equal to weight of A. But weight of A is also equal to mass of A times 9.8. So I just replace that. Since weight of A is equal to mass times 9.8. So now we can divide by 9.8, which gives us mass of A is equal to 0.27 kilos. So let me just circle that in yellow. Right, that's the first answer. All right, so that's the mass. Let's see what else we have to do. We need to find the speed of A. So let me just remove B. So find the speed of ball A. So let's have a look at our equations. Now, if you notice our equations, we don't have any equations that include the speed, and so we'll have to adapt to that. So acceleration, centripetal acceleration, this is here. So this variable over here is centripetal acceleration. So I'm just we can rename that. This is equal to centripetal acceleration. I'm just gonna write here centripetal acceleration. That's the kind of acceleration we have, and we have equations for those. So centripetal acceleration is equal to, I'm just gonna write it here, equal to radius times angular velocity squared, but it's also, there's another equation for it as well. It's equal to speed squared over r. So we can replace that in this equation. Since we have the mass, we have the tension, and we have the other tension. We can find A, but we're missing radius. So let's have a look back at our problem. They tell us that rope 1 makes 30 degrees, and rope 1 is 1.5 meters long. So let's find the radius for A. So we want to find the radius. This is 1.5 meters, and that angle is 30 degrees. So we can find the radius by doing 1.5 times sine of 30. 1.5 times sine of 30, which gives us 0.75. So this is 0.75, which is the radius. So let's go back. R is equal to 0.75. Okay, so now let's try that. Let's try to solve that. So I'm just gonna bring this equation down over here. I'm going to let's just actually I'm just gonna write it again. So force in x is equal to T1. T1 was 3.58, I believe. 3.58, right? So 3.58, I'm just going to replace it now. Cosine of 30 minus 0.75 cosine of 36.9 minus, the mass, which was 0.27. So that would be 0.27 times 9.8. Oops, I'm just going to rewrite that. Times 9.8. Whoops, I copied the wrong equation. All right, just try again. I'm just going to remove that. I was copying the fy equation. So let's just change that over here. And right, so we can just remove that here. Okay, so 3.58 sine of 30 and minus 0.75 sine of 36.9, and that's equal to mass of A, which is 0.27 times A, which we're trying to find. So let's do that. So 3.58 sine of 30 minus 0.75 sine of 36.9 divided by 0.27. That gives us acceleration to be 4.96. And the units for this are meters per second squared. So let's look back at the equations that we have. We have this one that includes the speed. So this is the one we're going to use. AC is equal to V squared over R. Now that we have R, we can find it. So AC is equal to V squared over R. Let's replace. So 4.96 is equal to V squared over, and the radius was 0.575 meters. So let's multiply that by 0.75. So that gives us 3.72 is equal to V squared. And now we can square root that, which gives us 1.93 meters per second is equal to V. So that's the answer for C, I believe. Or C, yes, okay. So this is what we have right now. Let's continue. So that's the speed of ball A found. Can remove that. Find the centripetal force acting on ball A. Now that we have the acceleration, this is really easy. So centripetal force acting on ball A, so that would just be F is equal to MA is basically what they're asking us. They want to find F. Since we already have M and we have A, M was, I forgot the, it was 0.27. So 0.27 times the acceleration, which we found to be, how much was it? 4.96 or something? 4.96, right? Okay, so times 4.96, and that is 0.27 times, oops, I wrote 0.96. Times 4.96 times 4.96, which is 1.34. 34 newtons. So that's D done. Find the net force acting on ball B. So let's do that one. Find the net force acting on ball B. We can use these equations that we have. So the net force would be, we can separate it into unit vectors as it would be easier for us. But the net force is just, if you find, they basically asking you to find Fx and Fy. So yeah. So since Fy is already 0, then that's pretty much done for the Y force. So we just need to find the X force. So we don't really know the acceleration, but we do know tension, so we only need that. So sum of forces in X is equal to T2 sine of 36.9. And that we can just replace. T2 was, what was T2 again? 0.75, right? 0.75. 0.75 sine of 36.9 and 0.35 sine of 36.9. That gives us 0.45 newtons for the force in X, and the force in Y is 0. Force in Y is 0. So the total force for B would be 0.45 I. That's the unit vector notation. So 0.45 I, that's done. Last one, if at the instance shown, I'm just gonna remove that. If at the instance shown, the string connecting A and B breaks, describe the motion of ball B. Now, for this question, I'm thinking like, what are they asking us? But basically, they're asking us like to I'm guessing describe where B would go, and I'm thinking it will go in the tangent. If let's say there is here, let's look at it from above. So that's the ball B. This is ball B, and right now velocity is in this direction, acceleration in this direction towards the radius. So if the tension that gives the acceleration, basically, that's the tension that gives the acceleration, will break, where would it go? Well, it will go in the direction of the velocity, which is currently tangential to the radius. So I think that answers the question. So that's pretty much it for this question, guys. If you like the video, then give it a like. Comment in the give a comment if you like this this video. I'll respond to every comment. And yeah, that's pretty much it. Bye bye.